So today I'm going to discuss solution of this Codeforces educational round 160 rated for division 2. So in this video I'm going to discuss the first problem. So let's now begin with problem number A. The name of problem is rating increasing. Rating increase. So what problem is asking us to do is simply they are giving us two numbers A and B and telling us that A is a smaller number and B is a smaller number, and they are written in the form of A comma B. Right here you can see A and B, and they are written in this form. You can see A comma B, and they have given a condition that where B is greater than A, right? Means A is smaller number than B, and they are given us a string such that A and B are written in this form in this string, right? So I have to tell them whether there is two numbers A and B such that B is greater than A in this string, or whether there is no solution existing. For example, in this example number 1, you can see I can write it as 2000 and 2001 differently, and here it can, you can see I can write A as 3 and rest B as 91125, and similarly. But you can see in this case, you can see I cannot write two different numbers such that my second number is greater than my first number. Here you can see the smallest number I can make is 200, because next number cannot have leading zeros. So smallest number A can be 200, and the largest number B can be also be 200. So they are both equal, which means answer is -1. But in next case, you can see my A is 200 and my B is 1000. So in this case, my answer is existing. So you see the answer is pretty much easy in this case. You can see it is only an implementation type problem. So whether I have to tell them whether they are existing a substring or prefix of string such that that prefix is smaller than my suffix of remaining part. So if I show you its code, it is also pretty much easy. First of all, what I'm taking the input S and checking whether my first number is 0 or not. If my first number is 0, then my A is a leading 0 number, which means A will be having a leading 0. In this case, my answer cannot never exist, right? So let's now continue. So now I'm checking whether my current string is 0 or not. I cannot start another number from 0. That's why I'm breaking it here. But else, I'm calculating a string A as 0 to I and string B as the remaining part. I simply calculating its integer part. But the integer part of A is smaller than integer part of B, then my answer is this, and I will simply put A and B and return from here. Else, if any of the condition does not satisfy, then I will simply put -1, and it is my answer. So let's now begin problem number B. The name of problem B is swap and delete. So it is a pretty much easy problem and an observatory problem. If you have a good observation skills, you can easily do this problem, right? So let me understand problem this here. For example, you are given a string like one, mm, right? For example, you are given a string like this. Here it is, right? So now what they are asking us to do simply, this is my original string. I can perform two type of operation on string. In a single operation, I can delete any character of the string. For example, if I delete this character, I can delete this character. But for deleting a character, the cost of that part is absolutely 1, right? But there is also second case in which I can swap any of the two numbers from a string. For example, in this case, you can see I can swap any two numbers. For example, if I try to swap this one with this 0 with this one, so I can write it here 1 and write it here as 0. So but this operation is costless, which means I can perform this operation in zero cost, right? So this is the condition for the my question. Now I have to tell them whether I can form another string. For example, let this string be S. So whether I can form another string T such that my none of the character of S and T matches. For example, let my string S be like 0, 1, 2. Then my string T can be 1, 0 and 1. Which means adjacent characters of my string S and string T should not be equal. Right. So this is the condition. So if my string S is like 1, 0, 0, my string T cannot be 1, my string T cannot be 0, 1 and 0, because you see in this case my these two characters are matching, so answer is not existing. So whether I have to tell them whether there is a string T such that s my any of the existing letter in S is not equal to that part of T, right? So how can I solve this operation question? So there is a pretty much it is a pretty much easy question. I'll tell you why. So first of all, tell me, the second operation is costless, right? So which means I can perform my second operation any number of times, right? So how I can further approach this problem? So let's suppose if my string is like this, right? And I can what is a valid string t which I can form? A valid string t which I can form is, there is one more case. For example, if my string s is like this, and if I did every other character in string s, and my string t become empty, then in this case my answer also is this, because you see my string t is not equal to string s in any of the adjacent character, right? So uh, what should my ideal string t look like? So in this case my ideal string t would look like something like this: 1 0 1 0 0 0 and 1 1 1 and again 1 0, right? So if it is my s, my string t should look like this, at least minimum this part only. So right, suppose how many ones I have in this question. So total I have at most 1 2 3 4 5, total 5 number of ones. And how many zeros? Similarly I have 5 zero also: 1 2 3 4 5. I have 5 zero also, right? Which means if I try to place, so which means if I try to place one here, I can easily place it, right? I can place it. My one is decreasing to 4, right? I can place a 0 here. It is also decreased to 4, and I can again place it 0 here. Then my 0 will again decrease to 3. Then again 1 over 0. Here it is 1. Sorry. It is 3. And then if I cut a 0, then it will become 3. And similarly, you can see I can satisfy all of the condition, which means total I need 1, 2, 3. 3 number of zeros I have. Total I need 3 number of ones I have. Which means in this case I need 0 number of delete operations required. I can only make my string not equal to t by using swap operation, or which are costless, right? But you see in this test case, this is a great test case. So tell me, first of all, what should a ideal string t look like? In this case it should be here 0 0 0 0 and 1 and 1. Now I will calculate how many ones I have. Total number of ones which I have is 4, and total number of zeros which I have is 2, right? Total number of zeros which I have is 2, right? So now tell me, can I place 0 here? I will check my 0 number of zeros. Yes, I can easily place a 0 here. Now it will decrease to 1. Can I place again 0 here? Yes, I can place. Now I will again decrease it to 0. But you see now I again require another 0. But my number of zeros are zeros, which means I cannot place 0 here. In short, I have to delete all these numbers, which means I have to delete all these numbers in the end. So total number of delete operations required are 4. So in this case my answer is 4. Here you can see my answer is 4, right? So this is a pretty much simple explanation of this problem, which means first of all I will try to construct the ideal string t which should it would look like by using the number of zeros and number of ones in my original string. But if any point my number of any number get exhausted and it is required at that moment, then my answer does not exist. I will break it here only, and the rest numbers are not needed, which means I have to delete the rest numbers in my string t to make it not equal to string s. So if I show you the implementation, here you can see, first of all I will calculate the count of ones and count of zeros, right? Then I will check if my current number is 1, which means I require to place a 0 here, right? So if my count of 0 is greater than 1, I will simply decrease it, else I will break. Okay. But if my current string is 0, which means I am requiring to place a 1 here, which means I will simply check whether there are remaining ones or not. If there are remaining ones, then I will decrease my ones, else I will break it. But if any point my string is breaking in between, then I will simply print the remaining numbers which are required to be deleted. So that is my answer in this case. So this is how problem intuition of problem will be. So now let's begin problem number C. So it is a pretty much easy problem, or I can say intuitive, more about. So what problem is asking us to do simply, the problem will be giving us some number of queries, right? The query one is defined as I will add 2 to the power x in my multiset, and here x is my number, right? And you can see they will also give us a string w, which means I have to tell them whether the existing numbers which I am accumulating from the step number 1 can form a can form an integer w by their sum at any means. Then I will print yes, then else I will print no, right? So I hope so you have understood problem pretty much. So how to approach this problem? Mm, so how to approach this problem, right? So right, so you see, let's debug some number of test case. They are first of all giving us some number of ones, which means 2 to the power 0, 2 to the power 0, 2 to the power 0, right? Now they are asking us to do simply whether I can make a 3 or not. It is only 1 1 1, so by adding them I can make a 3 easily. So in this case my answer is yes, but I cannot make 4. So okay, so in this case my answer is no, right? So similarly you can debug the second axis also. I can make all the numbers required. So but how to deal this problem? How I can um, you can say greedily approach this problem? So let's suppose I have some number of mm, 2. I'm only calculating the 2 power of 2's. For example, I have some number of 2's right here. Okay. Some number of 4's also given to us, and some number of 16, and I am also given a 1024, which is 2 to the power 10. So okay. So if this is my multi-set, so I will simply first of all calculate the each amount. For example, my number of 2's are 4, my number of 4's are 3, my number of 16 are 1, and my number of 1024 are indeed 1 only. So okay. So now I does not need this array. This information is enough only. So if I give you a number, you have to tell them, you have to tell me whether I can form a number using these numbers. Okay. If I give you a number, you have to tell them whether I can make a number using only these numbers. So how you can approach this? Right. So how can you approach this problem? Right. For example, if the let's suppose the given number is 32. Given number is 32. So first of all, I will simply calculate the first of all I simply calculate the number requiring 32. So my number is indeed 32 only. Okay. Now I will start iterating from the back and check what numbers are available to me. So first of all, I'm available at 1024, right? I'm also available with the 16. I'm also available with some number of 4s. I'm also available with some number of 2s, right? It is 1, it is also 1, and the count is 3, and here it count is 4, right? So I have written all the numbers which I have and which I want to achieve. So I will start iterating from the left to right in the increasing order. I will check how many how many 1024 can this 32 contain. Let me repeat, how many 1024 can be contained in 32. So it's suppose it is a pretty much easy. The answer is 0, because you can easily say my 32 is more than 1024, so none of the 1024 can lie under 32. Okay, suppose now I will came to this position. Okay, now I will do how many 16 can we fit inside my 32. Okay, how many 16 can we fit inside my 32? And the answer of this is 2, which means I can break down 32 into 2 number of 16, right? Okay, but how many I have? I'm only having one number of 16, right? So I will utilize it. Okay, right? So by utilizing the at most number of 16 available to me, my 32 will be remaining 16 only, right? Okay, and this part is cancelled, and the count of I can say the count of 16 become equal to 0. Now I will came to this position, right? Okay, so now tell me my current number has become to 16 only, right? My current number now has become to 16. Okay. Now tell me how many number of 4 can lie inside a 16. Which means how many number of 4 can lie inside of 16. The answer of that is 4. Which means I can break 16 into 4 number of 4s. Okay. But how many number of 4s I have? I'm only having 3 number of 4s. Right. So I will utilize them. I will utilize them. So by utilizing 3 number of 4s, how the number which is left to me is only 4 only. Which means 12. I can say 16 minus 4 into 3, which is 12, which is 4 only. Okay, now my new number will be, now I can say my remaining number is 4 only, right? So now I will came to next position. In the meantime this has become equal to 0. Now I came to this position. So now tell me how many number of 2 can reside inside a 4. How many number of 2 can come inside of 2? How many number of 2's can come inside of 4? That is 2 only, which means I can break down 4 into 2 number of 2's, right? Okay, but how many 2 I have? I have 4 number of 2's, right? So I will utilize the mm, I will utilize the at most number of 2's which I can utilize. I am only needing 2 number of 2's, but I have 4 number of 2's, so I will only need 2 number of 2's, which means I can make like 2 into 2 equal to 0, right? Which means I can achieve this number. Initially I am having 32 as a number, but by utilizing these numbers in a certain way, I am getting 0, which means I can make a sum as 32 using this operation. So I hope you have understood this test case. So let me tell you another test case. Okay, it is pretty much greedy problem. I'm only telling you another test case. I hope you have understand the code. You have understood the approach till this time. So let's suppose my number of 2's given to me. Let's suppose number of 1's given to me are, let's suppose 16 number of 1's I have given, right? Okay, my number of 2's, let's suppose it is 1 only. My number of 32's I am having, let's suppose 3. Okay, my number of 64, let's suppose it would be 1. Okay, now tell me whether, suppose I am giving a number like 1, I am having a number like 151. Suppose this is a number given to me, so I will write it down here in the decreasing order. First of all 64, then 32, then number of 2's, and then number of 1's. And how many number of 64? It is 1. How many number of 32's? 3. Number of 2's? 1. Number of 1's are 16. So I will start adding from the left to right. Okay. So now tell me how many 64 can come inside 151? How many 64 can come inside 151? The answer of that is 2. Okay. Okay, which means I can make it as 64 plus 64 plus another number. That can be any much. But how many 64 cannot come? I cannot reside 364 inside 151, which means my answer of this problem is 2, which means I can reside two numbers of 64 inside 151. But how many 64 I have? I'm only having 164, so I will utilize that 64, which means I can simply write here as 151 minus minimum of required, comma, I'm having. So I will simply write it here 1 into 64. So what it is? 151 minus 64, so it is 87, right? Suppose, so my new number will now become as 87. Okay, my new number is now 87. Okay, and I will erase this part. So now I will came to this position, 32. How many 32 can come inside 87? That is 2 only, which means how many 32 can came inside 87? The answer of that problem is 2, right? Suppose, and how many 32 I'm having? I'm having 3 number of 32, so I will utilize at most, which means I will subtract 82 minus minimum of required, comma, I'm having. So that is 2 only. 2 into 32. So that is again 64 only, which means 87 minus I can say 64. That is 20 is 23. Okay. Now the next number which I am getting is 23. Okay, is 23. Okay. Now I will come to next position. To this position. Okay. At this position. So now tell me how many two can decide under 23. The answer of that problem is 11. Okay, yes, you can say absolutely 11 number of 2 can come inside 23. But how many 2's I am having? I am only having one number of 2. Okay, so I will simply subtract 23 minus minimum of required comma I am having. That is 1 into 30, but that is 1 into 2. That is, now I will get 21 here. Okay, now my next number will become 21. Okay, now what next? I will come to this position. So how many one can come under 21? That are 21 number of ones. Okay, but how many ones I am having? I am only having 60 number of ones. So I will simply subtract the 21 minus minimum of required comma I am having, that is 16 into 1. Then in this case I will be remaining with number 5. So now you can see I cannot go further at all. And my number is not boiled down to 0 also, which means I cannot make 151 from this sequence or in this order. Okay, which means if I am able to make this 151 as a 0, then my answer is this. But if that is greater than 0, which means I cannot make a 151 from this. So here you can also make a conclusion like I'm having 151 and I'm remaining with 5, which means I can make 146 from this sequence, but I cannot make 151. So it is a pretty much clear observation. So now I will show its code. So first of all, what I am taking, I am first of all maintaining an array like have. Is have suggested whether I am having a how many numbers, how many current numbers I am having. For example, you can say I have one number of 64s. I have three 32s. So it will show that part only. Okay. I will simply increase the have part. Yes. Now what I am get now for checking for checking whether the current number can be formed or not. So for calculating that part, I'm first of all calculating the bit set of that number and finding what is that number in actual numbers. Okay. So in this form of 2 to the powers, I'm calculating that number. I will calculate the number well. Okay. Now what I will do, I will simply check how many numbers of current power, which means if I'm at this position, how many number of 64 I am requiring. So first of all, I'm calculating how many number of 64 I am requiring by dividing it by 64, or I can take by the current number. I will get a k. Okay. Then I will subtract the minimum of, yeah, remember what I am doing. The requirement, comma I am having. Minimum of requirement, comma having. I will subtract the minimum required comma having multiplied by the number which I am on currently on. For example, in this case it was 64. So I will simply subtract that number. So by using this operation, if at the end my value become equal to 0, then I will print yes, else I will simply print no and return. So this is the whole problem intuition problem number C. So it is a pretty much easy problem, or I can say intuitive more about, or you can say there was much about more number of summation than expected in problem number C, and there is a huge gap between C and D also. So if you have any doubts in this problem set, you can comment me down. Until then, stay tuned for the next one. Thank you.